everyone, welcome to Mathworld. This is Cambridge International AS and A-Level Mathematics Paper 3 for October-November 2022, and the code is 9709/31. Alright, let's get started. Now, first question, 1a, sketch the graph of y equals to modulus of 2x plus 1. So to sketch the modulus graph, first of all, we will ignore the modulus sign, which means we are sketching y equals to 2x plus 1. So when x equals to 0, your y will be 1. Then we get the first point with coordinates 0, 1. Now when y equals to 0, 0 is 2x plus 1. Therefore, our x is going to be negative half. Right? So our second point is going to have the coordinates of minus half followed by 0. So now let's sketch the graph. Draw the xy axis together with the origin. Now let's say this is 1. Okay, and here is minus 1. Now we get 2 points, 0, 1, which is the point on the y-axis, and another point is negative half, 0. So let's say here is negative half. Alright, so we are going to draw these 2 points, to join these 2 points using a ruler. So I will use straight line or solid line to join the 2 points, and then our original line should have negative values, negative y values, which is by using the dotted line. Now I draw the dotted line for the values of y which are less than 0, or they are below the x-axis, because of we are sketching the modulus graph right now. So the modulus graph means that there's no negative. So for all the dotted line, it should be reflected on the x-axis, and this is our graph for the modulus of 2x plus 1. Okay, so now let's move on to the next part. Now solve the inequality 3x plus 5 less than modulus of 2x plus 1. Now basically for this question, we have two ways to solve the question. Alright, so the first way is using the graph. Since the graph is already sketched on the part A, then I'm going to use the graph to solve this problem. So now the second method is just use the definition to solve it. Alright, so I need to add one more graph, which is y equals to 3x plus 5. So now, before I sketch a graph, I will get the intersection points first. So let x be 0, my y is going to be 5. And let y be 0, my x is minus 5 over 3. Okay, so here I get 2 points, 0, 5, and another point is minus 5 over 3, then 0. So now I will add these 2 points on the graph in part A using green color. So now my first point is 0, 5. So it means that, let's say here is 5. Just an example. Here is 5. And then another point is negative 5 over 3, 0. So let's say here is minus 2. So this is going to be minus 5 over 3. So now join these 2 points using ruler. So let's say I'm getting this line. This is y equals to 3x plus 5. Okay, so now based on here, for you to solve this inequality, the straight line is less than the modulus graph. Okay, so the straight line means a green color, less than the straight line, less than modulus graph. So the green line is below the blue line, which means it will be for all these values of x. Alright, so now we need to find the intersection between these two lines, the green color and the reflected blue line. So now for your information, the blue line is the reflected graph. Therefore, your equation becomes negative of 2x plus 1. Okay, so now we have to find the intersection points between y equals to negative of 2x plus 1 and y equals to 3x plus 5 before we get the solution from the graph. So now y equals to 3x plus 5 as the first equation, and then the second equation is negative of 2x plus 1. So now when we solve both equations, I will let first equation equals to second equation, then 3x plus 5 equals to negative of 2x plus 1. And now we do expansion. So negative 2x minus 1 equals to 3x plus 5. Alright, so from here, by moving the negative 2x to the left-hand side, I will be getting 5x. Then move the 5 to the right side, it will be minus 6. Hence, the intersection point is at x equals to minus 6 over 5. So this point is minus 6 over 5. Right? So as I've mentioned from the graph just now, right? So as I mentioned just now from the graph, we know that as long as it is less than this intersection point, the straight line, the green color, is less than the blue color. So which means the solution is x less than minus 6 over 5. This is your solution. Okay? Now, question 2. On a sketch of an Argand diagram, shade the region whose points represent complex numbers z, satisfying the inequalities modulus z less equals to 3. RE means the real part. Okay, real part of z squared equals to minus 2, and the argument is between pi over 4 and pi. So now, for your information, this modulus z less than equals to 3 is actually the equation of, or I would say that it is inequality of a circle. Okay, so this is a circle equation with center 0, 0. Here is the coordinates of the center, and then the radius is going to be 3. Right? So for RE z squared equals to minus 2, we will let the z be x plus yi. So the RE is the real part, which means it is x. So now you need to shade the region for x squared equals to minus 2, and now followed by argument between minus pi over 4 and pi. So the argument is the angle from the complex number. So it means that first of all, we have to sketch the circle with center 0, 0 and the radius 3. So let's say here 0, this is 3, here is 3, here is 3, negative 3, and this is negative 3. So now we get few points. Right, so draw the circle. Okay, let's say this is a circle. Please draw the smooth circle. All right. So make sure the distance is the same. So maybe I just adjust my y-axis, then it will be easier. All right. So here is 3 minus 3. Okay. So now from here, we have to label our axis. So the vertical axis is basically the imaginary of the z, and this horizontal is the real part of the z. Okay, now, so when you look at the first inequality, it's basically a circle, the region which consists of the circle and also the region inside the circle. Okay, it's the boundary of the circle and also the inner region. All right. So for the second part, which is x squared equals to minus 2. So let's say here is minus 2. We use a straight line here, the solid line, because of the equal sign. Okay, here x squared equals to minus 2. Otherwise, we have to use a dotted line. So then the argument is between between positive pi over 4. There's no minus. Okay, between positive pi over 4 and pi. So now pi over 4 is 45 degrees. And same explanation, because there's an equal sign here. Right? Okay, so there is an equal sign, therefore you have to draw solid line. So solid line, and then we will label the angle as pi over 4. So the angle is counted from the origin. So this is origin. And then it's up to pi. Pi is horizontal line over here. So now when you look at the region, it should be the circle together with the inner region. And then x greater equal to -2 means it should be all the regions above, towards the right hand side from the -2. This is -2. And then the angle is bounded by pi over 4 and pi, which means your shaded, the region, it should be here. Okay, so this is our shaded region that's satisfying 3 inequalities. Okay, so now question 3. Solve the equation 2 power 3x minus 1 equals to 5 times 3 power negative x. Give your answer in the form of ln A over ln B, where A and B are integers. So first of all, I'll copy the question. Alright, so now we take ln both sides. Please be remember that there's only one ln allowed. Okay, so there's a power for the 2. The degree for the 2 is 3x minus 1. Now use the formula ln A power B is B ln A. Okay, and at the same time there are 2 terms here. Multiplication of 2 terms but with 1 ln. So I will say that ln AB is ln A plus ln B. So now by bringing down the 3x minus 1, I will get 3x minus 1 ln 2 equals to, for the right hand side, you split it into 2 ln, so it becomes ln 5 plus ln 3 power negative x. Then the negative x, you will bring it down because of the first formula. So the minus x times plus becomes minus, so minus x ln 3. Okay, so for the left hand side, you will just do expansion. So I will get 3x ln 2 minus ln 2. Now, to solve the equation means that you need to find the x. So the minus x ln 3 on the right side should be moved to the left hand side and factorize the x because it is in common. So I will get x bracket 3 ln 2. Then this term, when you move to the other side, it becomes plus ln 3 after you have factorized the x. And then for this minus ln 2, on the left hand side, you will have to move it to the right side. So I will get ln 5 plus ln 2. Okay, so now to get the x, since you need to get the ln A over ln B, where the A and B are integers, then you need to combine. Okay, and now to combine the 2 ln, use the second formula. It becomes ln 5 bracket 2 over 3 ln 2 is ln 2 cubed. But because of the plus, and again now use the same formula, becomes times. So here becomes ln 10 over ln 24. Okay, so here we found the A equals to 10, B equals to 24. Okay, so that's all for the question 3. Now, question 4. Solve the equation tangent x plus 45 degrees equals to 2 cot x, where the x between 0 degrees and 180 degrees. So now, tangent x plus 45 degrees is 2 cotangent x. So now, use this tangent formula. Tangent A plus B is tangent A plus tangent B over 1 minus tangent A, tangent B. Okay, so now your A is x, B is 45 degrees. So I will get tangent x plus tangent 45 degrees over 1 minus tangent x, tangent 45 degrees, that equals to, now the cot is basically 1 over tangent x. Okay, now tangent 45 degrees is 1. So you may simplify it to be tangent x plus 1 over 1 minus tangent x. Then the right hand side will be 2 over tangent x. Okay, so to solve the equation means that you need to find the unknown, which is the x. So now we will be using the cross multiplication. So tangent x multiply with tangent x plus 1 is going to be 2 brackets 1 minus tangent x, right? So now do expansion, you'll be getting tangent square x plus tangent x on the left hand side. And then for the right hand side, 2 multiplied by 1 minus tangent x is going to be 2 minus 2 tangent x. And then I'll rearrange all the terms so that all the terms are on the left hand side. So you'll be getting tangent square x. So here, the minus 2 tangent x plus with the tangent x on the left hand side, it becomes 3 tangent x. So the plus 2 on the right side will be moved to the left side, becomes minus 2. And let it be 0. So to solve this quadratic equation, okay, you may use the calculator to get the solution. So tangent x will be 0.5616 and negative 3.5616. Alright, so now refer to the given x values, x from 0 to 180 degrees, which means it will be in first and second quadrant because your tangent values are positive and negative. So now this is the first angle and followed by second angle. So from here, your x will be 29.3 degrees and 105.7 degrees. Okay, so with this, we have solved the question 4. So now, let's move on to the next question. Question 5. Complex numbers u and w are defined by u equals to 2e, 1 over 4 pi I, and w is 3e, 1 over 3 pi I. Now, find u squared over w, giving your answer in the form REI data. This is a Euler form, where r greater than 0 and then theta between minus pi and pi. So inclusive pi. Give the exact values of r and theta, means no decimal. Okay, so first of all, I will write down the u, 2e, 1 over 4 pi I. So from here, the r, okay, or I would say that this is a u, the modulus. Actually, the r is a modulus, the theta is the argument. So the u is going to be 2 because this is REI theta, right? So the argument u is 1 over 4 pi. Now, from the w equals to 3e 1 over 3 pi I, your modulus of w is 3, then the argument of w is 1 over 3 pi. Now, for u squared over w, before you get the Euler form, which is the REI data, we need to get the modulus first. So the modulus for this becomes modulus of u squared over modulus of w. So which is 2 squared over 3. I will get 4 over 3. So same for the argument of u squared over w is basically argument of u squared minus argument of w. So argument of u squared is argument u plus argument u, which is 2 argument u. Then minus argument w. So 2 argument u, alright? So replace argument u by 1 over 4 pi. Then you minus argument w is 1 over 3 pi. So at last, you will be getting 1 over 6 pi. So with the modulus and the argument, then we can easily express the complex number in REI data, the Euler form. So I will write u squared over w equals to 4 over 3 e 1 over 6 pi I. So this is our solution. Okay. Now B, state the least positive integer n such that both im, this im is the imaginary part of w power n equals to 0, and the real parts of Wn greater than 0. Okay, even though it is only state with 1 mark, but I will explain step by step. Okay, so now, firstly, write down the Wn first, W power n. So your W is 3e 1 over 3 pi I. So 3e 1 over 3 pi I with degree n. Okay, then now based on the idea from the first part, okay, we know that if you consider degree n of the Euler form, the new modulus is going to be degree n, and then the argument is multiplied by n times, or you add it for n times. So here can be simplified into 3 power n e 1 over 3 n pi I. Okay, so now in order to get the imaginary and real part, then I will do extension for the e. So we will express in the polar form. So the polar form is pi cos 1 over 3 n pi plus I sine 1 over 3 n pi. Okay, so from here, my imaginary part is going to be 3 power n together with the sine. This is my imaginary part. And then for my cos, it's going to be 3 power n. For my real part, okay, it's going to be 3 power n times the cos. This is my real part. All right, so now let's refer to these two conditions. So imaginary part of W power n equals to 0, which means 3 power n sine 1 over 3 n pi is 0. Then real part of W power n is greater than 0, which is our second condition. So it's going to be 3 power n cos 1 over 3 n pi greater than 0. Now we know that 3 power n will be positive, right, for regardless of the n values. So from here, it's basically solving sine 1 over 3 n pi equals to 0, and at the same time, cos of the same data will be greater than 0. So now let's refer to the cos and sine graph. So now firstly, I refer to sine graph. This is 2 pi. Here is sine, then 0. Then for the cos graph, here's 2 pi. So when 2 pi and 0, I'm getting 1. Pi, I will be getting minus 1. Okay, so this is y equals to sine x. And the second graph is y equals to cos x. Okay, so now let's see the first condition. Sine equals to 0. Now, since your n is positive integer, so we will not consider 0 for the whole angle. Therefore, we will consider pi first. But when you consider pi, okay, sine pi, so it will be 0. At the same time, the cos pi will be negative 1. So it does not fulfill the second condition, which means now we have to consider 2 pi. So if the whole angle is 2 pi, for sine it will be 0. Then for the cos, it will be positive 1. Therefore, I know that my minimum angle that satisfies this sine angle is pi is 0, and also cos angle more than 0 is going to be 2 pi. Okay, this is my minimum angle. So now cancel pi from both sides. Therefore, 1 over 3n equals to 2. Hence, my n will be 6. All right, so you can just write down the least positive integer n is going to be 6. Okay, so this is an explanation for B. Now, question number 6. A, prove that the identity cos 4 theta plus 4 cos 2 theta plus 3 equivalent to 8 cos degree 4 theta. So when you need to prove the identity, you either start from left side or right side. But obviously, left side has 3 terms. Therefore, we will start with left-hand side so that you can simplify the terms. So cos 4 theta and cos 2 theta, I need to get my answer in cos theta to the power of n. Okay, so therefore we have to refer to the cos 2 theta formula. So instead of writing cos 2 theta, I will write cos 2a, which is 2 cos square a minus 1. And then I will compare what is my a. Now, for cos 4 theta itself, we change to cos 2 bracket 2 theta. And then for the next term, which is cos 2 theta, here 2a, which means your a is theta right now. Then I will be getting 2 cos squared theta minus 1, then followed by plus 3. Okay, so now for the first term, cos 2 bracket 2 theta. So again, you compare 2 theta with the a here, which means my a is 2 theta. So I will be getting 2 cos squared 2 theta minus 1. Okay, then multiply the 4, you will get 8 cos squared theta minus 4 plus 3. So for your information, the 2 cos squared 2 theta is basically 2, then cos 2 theta and squared outside. Okay, it's the same. But then for the cos 2 theta, I'm going to use the formula again. So now my a is the theta. That means I will be getting 2 cos squared theta minus 1. Okay, then don't forget the minus 1 at the back. Plus 8 cos squared theta minus 4 plus 3 is minus 1. Okay, so now we need to do expansion for the square. This is a square. So I will get 2 bracket square of 2 cos square minus 2 cos square theta minus 1 is basically 4 cos degree 4 theta minus 4 cos degree 2 theta plus 1. Then, when you look at the remaining terms, the minus 1 and minus 1 becomes minus 2. So I will get plus 8 cos squared theta minus 2. Okay, so next step, just do expansion. I'll get 8 cos degree 4 theta minus 8 cos degree 2 theta plus 2 plus 8 cos squared theta minus 2. So from here, minus 8 cos squared plus 8 cos squared can be cancelled off. And then here plus 2 and minus 2 will be cancelled off. So we only have 8 cos degree 4 theta. So this is how I solve this, or how I prove this identity. Okay, and since this is an A, then now we have solved A and then we move to B. So B hence solve the equation. Alright, so hence means copy the answer or use the answer from previous part. So I will copy the identity that we have proven just now. Cos 4 theta plus 4 cos 2 theta plus 3 is 8 cos power 4 theta. So cos 4 theta plus 4 cos 2 theta plus 3, significant, yeah, plus 3 equals to 8 cos power 4 theta. Okay, so from this identity. Now we need to prove, you want to solve this. Okay, you will notice that these two terms on the left-hand side will be same as the identity that we have proven. Therefore, now I copy the question. Okay, so to get these two terms, we will have to move the 3 to the other side. So I will get 8 cos degree 4 theta minus 3 equals to 4. So now 8 cos degree 4 theta equals to 7. So cos degree 4 theta is 7 over 8. Now we need to solve means that what is the theta? Alright, for the theta between 0 and 180 degrees inclusive. So now your cos theta, by moving the power 4 to the other side, since the power is even number, it should be plus minus 4th root. Okay, and now by looking at the theta values, it will be in first and second quadrant because of the plus minus in your in this step. Right? So when you use the calculator, you will find that the basic angle is 14.7 degrees, right? So when you take inverse cos of square root 7, the fourth root of 7/8, you'll get 14/7. So another angle is the major angle, which is 180 minus 14/7. So your theta is going to be 14.7 and 165.3 degrees. Okay, these are the two angles that satisfy the equation. Okay. Now let's move on to the next question, number 7. The equation of a curve y equals to x over cos square x. Okay, the equation of the curve is y equals to x over cos square x for x between 0 and half pi inclusive 0. Now at the point where x equals to a, the tangent to the curve has gradient equals to 12. So from here, you should understand that when x equals to a, gradient of tangent is basically dy dx. So it is 12. Now you want to show that a equals to this formula. So what to do is, before you apply these two values, then we have to differentiate the y with respect to x. So now this is a division of two functions of x, therefore we are using quotient rule. So differentiate u over v with respect to x, it will be v squared in the denominator, and then vu prime minus uv prime. Right? So now you may write down your u first. Your u is x, your v is cos square x. So for your info, cos square x is basically square of cos x. Right? So now u prime is 1, v prime is, bring down the 2, remainder cos x, degree becomes 1, and then differential cos x is minus sin x. So here I'm getting negative 2 cos x sin x. Right? So now use the formula, the quotient rule, this green color, then substitute all the terms. So now I'm getting v squared, which is cos square x squared. So numerator cos square x. Alright, so vu prime. vu prime is 1 minus uv prime x. v prime is negative 2 cos x sin x. Okay, so from here, I notice that you have the cos x for numerator and denominator. Therefore, I will cancel off. I cancel off degree 1 of the cos x. So here still have degree 1, here degree 1. I mean, here supposed to be degree 4. Alright, so I will say, instead of square here, I would say this is cos degree 4. Okay, so now I cancel degree 1. So here left degree 3. Alright. So now I will get cos x minus is a plus 2x sin x over cos degree 3x. Okay, so now replace the x value and dy dx value. So dy dx is 12 when the x is a. So I'll get cos a plus 2a sin a, then over cos cube a. Okay, so now after this step, please refer back to the question here. We need to prove a is arc cos cube. Okay, not cube, cube root of this whole term. So before you get arc cos, I should get the cos first. It will be cos a, and by moving this cube 1/3, the degree of 1/3 cube root, you should be getting cos cube a on the left hand side. Okay, so now from here, I should move up the cos cube a and move down the 12. So from here, right, so slowly move the cube to the right side, it becomes cube root. Then Move the cos to the right side, becomes inverse cos. Okay, so this is the form that we are proving, right? Okay, so B, verify by calculation that A lies between 0.1 and, between 0.9 and 1. So to do this verification, we need to get the equation, okay, or we need to get the function, the FA. So where to get the FA? Very simple, just make sure the right hand side is 0 by moving the inverse cos to the left hand side. So I will get A minus inverse cos cube root of cos A plus 2A sin A over 12 equals to 0. Then I will let all the terms on the left hand side be FA. Okay, now to prove that the A lies between 0.9 and 1, so now replace the A by 0.9, 0.9, and make sure there will be one positive and one negative for the FA. So replace first. So now, please take note on this calculation. Since your A is the value of the cos and sine, and without the degree sign, therefore, basically this 0.9 and 1 are radians. Okay, please make sure you change the mode of calculator to radians. So now, when you calculate this value, you will be getting negative 0.0846, which is less than 0. And now F1. Use the same formula and replace the 0.9 by 1 from the F 0.9. Okay, and then you'll be getting 0.0358, which is greater than 0. So 1 less than 0 and 1 more than 0, therefore there is a sign change. Okay, there is a sign change. Hence, A lies between these two values. So this is a sign change rule. Okay. All right. C. Use an iterative formula based on the equation in part A to determine A correct to 2 decimal places. Give the result of each iteration to 4 decimal places. So now from the formula or from the equation in part A. So equation in part A, to do the iteration, we need to add on the subscript. Okay. So the term on the left hand side will be added the subscript of n plus 1. Then for the A on the right hand side, it will be subscript of n. Okay, so now I rewrite A n plus 1 equals to inverse cos cube root of cos A n plus 2an sin A n over 12. Now, since in the part B, we have proven that your A lies between 0.9 and 1. So you can simply let the initial guess, which is A0, be 0.9 or 1 or the middle value. Okay, the middle value is going to be 0.95. So I'm going to use A0, A0 equals to 0.95, which is the middle value of 0.9 and 1. So with this A0, I will be getting A1 equals to inverse cos of the cube root. So cos 0.95 plus 2 times 0.95 sine 0.95 over 12. Okay, so this is going to be 0.9743. Now, how do we know when to stop this iteration? So now your final answer equals to 2 decimal places. Here is 95 for the A0, and now your A1 is 97. So they are different. Therefore, we have to continue with the next iteration. So my next iteration is going to be A2. Inverse cos, then cube root, cos 0.9743 plus 2an. So A1. Then sine 0.9743. After that, divided by 12. So when I calculate this value, it will be 0.9694. Okay, now, when we refer to first two values, they are not the same, but the third integer, okay, the third value, it is greater or equal to 5. Therefore, we will round up the 6 on the second decimal place, and now it becomes 97. So it is similar to A1. Therefore, we can stop our iteration and write down your A is basically approximate to 0.97. Okay? So now let's move on to question 8. In a certain chemical reaction, the amount X grams of a substance is increasing. The differential equation satisfied by X and T, T means the time in seconds, since the reaction began is dx dt equals to kxe negative 0.1 t, where k is a positive integer. Now, it's given that x equals to 20 at the start of the reaction. So, start of the reaction means when t equals to 0, right? The x is 20. Now, A, solve the differential equation, obtaining a relation between xt and k. So, now, first of all, I copy the differential equation. Now, we split the variables. So, move the x from the right side to the left side. It becomes 1 over x dx. And then move the dt to the other side. So, I will get k e negative 0.1 t dt. And now, integrate both sides. Okay, so for your information, to integrate the exponential function, you need to rewrite the whole exponential function, then divide by the differentiation of the e. So when you differentiate the power of the e, it will be a, then plus c. Alright, so apply this formula to integrate. Now, for the left-hand side, integrate 1 over x is basically ln x. Then the right-hand side, rewrite the whole exponential, divide by, differentiate the power of e, you will be getting negative 0.1. Then plus c. Now, before we replace the t and x value in order to get the c, you can simplify the denominator for the first term on the right-hand side first. So 1 over negative 0.1 is basically negative 10. So when I multiply with the k, I will be getting negative 10k exponential, then plus c. Okay, so now replace a t by 0 and x by 20. I will get ln 20 is negative 10k e power 0 plus c. So e power 0 is 1. Therefore, my c is ln 20 plus 10k. So after you found the c, substitute into this equation, then you'll be getting the final answer. So ln x is negative 10k e negative 0.1 t plus ln 20 plus 10k. So when you look at here, basically the 10k is in common, okay, for the first and third term. So I will write ln 20 plus 10k bracket, write out the last term first, which is 1, then minus the first term, e negative 0.1 t. Okay, this is our solution. Right. Now, B, given that x equals to 40 when t equals to 10, find the k value, this is the first part, and find the value approached by x as t becomes large. So t becomes large means t tends to infinity. This is our second part of this question. So now, before we get the k, let me copy down the solution first. Ln modulus x equals to ln 20 plus 10k ln 20 plus 10k bracket 1 minus e negative 0.1 t. So when t equals to 10, your x is 40. So now ln 40 equals to ln 20 plus 10k bracket 1 minus e negative 0.1 times 10 because the t is 10. So now I will simplify first. So 0.1 times 10 is basically negative 1. Okay, so 1 minus e power negative 1. This is ln 40. Now to get the k, move the ln 20 to the other side and divide by 10 of this bracket. Alright, so you can simplify this to 0.10965. Now here we do not leave our answer in correct to 3 significant figures because we need to approximate it. Or probably you write down this, then you write down it is 0.110 if it is 3 significant figures. So when you need to do calculation for next part, we are going to use the previous value, okay, more accurate. So from here, you need to get the x. You need to check the behavior of the x when the t becomes infinity. So I will rewrite my equation or my solution. So ln x equals to ln 20 plus, okay, 10k. So for this 10k, do not use this, but use the previous value. So where times by 10, it will be 1.0965. Okay, there is a 10k, then 1 minus e negative 0.1 t. All right, so now when t tends to infinity, so I'm getting e power negative 0.1 t. So e negative 0.1 t will tend to 0. Okay, so now my ln x equals to ln 20 plus 1.0965 times 1 minus 0 because here is 0. So now what to do is I will say approximate. Okay, it's not equal sign, approximate. So to get the x, you need to take e both sides in order to eliminate the ln. So when you do the calculation, it will be 59.9, which means when t tends to infinity, your x approaches to 59.9. All right. So now let's move on to question 9. So from question 9, you are given the diagram that shows part of the curve. This is a curve for x greater than or equal to 0 and the minimum point m. So this is a minimum point. Now A, find the exact coordinates of m. Means that you need to find the minimum point. So a minimum point is found by differentiating the given curve. So from here, you will notice that it is multiplication of two terms. To differentiate multiplication of two terms, it is using product rule. So differentiate uv is uv prime plus bu prime. Okay, so I will let my u equals to 3 minus x. My v is the exponential function. So my u prime is going to be minus 1. To differentiate exponential function, you need to rewrite and then differentiate the power of e. So when differentiate ax plus b, it's going to be a. So now my v prime differentiate negative 1 over 3x is negative 1 over 3. Then rewrite the whole exponential function. Okay, so now dy dx. U dv dx, so 3 minus x times -1/3 times the exponential function plus vu prime, exponential times -1. Okay. So from here, I may factorize the common term, which is exponential. So factorize exponential -1/3x. And then the remaining terms just do expansion. So multiply, right? -1/3 times 3, -1. -1/3 times -x plus 1/3x. And for the second bracket, since we have factorized the exponential, you still have the plus and -1. Therefore, it becomes -1. Now, when I further simplify the bracket, I will get -2 plus 1/3x. Okay, so now to get the minimum points, dy dx always 0. So now you write dy dx equals to 0. Therefore, exponential times the whole bracket equals to 0. But we know that exponential never 0. Therefore, -2 plus 1/3x will be 0. Now, solve this equation to get the x. So 1/3x will be 2. Hence, your x is 6. With the x equals to 6, now we need to get the exact coordinates of m, which means we need to count the y coordinate. So just replace the x equals to 6. Okay, just replace the x by 6 in the y equation. So here it's going to be 3 minus 6e -1/3x. X is 6. So at last you will be getting -3e -2. Okay, hence the coordinates of m will be 6 and -3e -2. All right, so that's all for this question. So now B, find the area of the shaded region bounded by the curve and the axis, giving your answer in terms of E. So now let's look at the graph. We need to find the shaded region. Means we need to find this intersection point, right? The intersection point between the x-axis and the graph. So this axis when the y equals to 0. Now I need to let the curve equation be 0. So when y equals to 0, you will be getting 3 minus x times exponential of -1/3x equals to 0. So again, e cannot be 0. Therefore, 3 minus x equals to 0. Hence, I get x equals to 3. Right? Which means this point is 3. So now to integrate or to get the area, it is a region below the towards the x-axis. Therefore, your area is going to be integrate y dx. The limits will be 0 and 3. So area equals to 0 to 3 y dx. So here 0 to 3, 3 minus x times exponential. So when we need to integrate this, you will notice that it is a product of two terms. The first is 3 minus x, the second is the exponential. Therefore, we need to apply integration by parts. Okay, integration by parts means integrate u dv dx equals to uv minus integrate v du over dx. So since you have limits now, so a to b, then just add on the limits. right? So now, when you compare, your u is 3 minus x, your dv dx is exponential function. So now our du dx is minus 1. Okay, so a short note, when you need to integrate e ax plus b dx, you need to rewrite the whole exponential function and then differentiate the ax plus b to get a. So it is in the denominator. So this is your formula. Now here is going to be v equals to e negative 1 over 3x over negative 1 over 3. So I will say that it is negative 3e negative 1 over 3x. Okay, so now here area equals to uv, so uv multiply together with limit 0 to 3 minus integrate 0 to 3 v du dx. So minus minus is a plus. So 3e negative 1 over 3x dx. Alright, so now when I replace the x value by the upper limit, so this 3, when you move in, 3 minus 3 is going to be 0. So I will just direct write 0. Then minus, replace the x by 0 now. So 3 minus 0 is 3, but then there is another minus 3 here. That means I'm getting minus 9e. So negative 1 over 3 times 0 is 0. Now to integrate the 3e minus 1 over 3x, you can factorize the 3. So let's integrate exponential. So which is here. Integrate exponential, I will be getting minus 3e negative 1 over 3x. Okay. So now simplify. So the first is 9 because e power 0 is 1. Here is 1. So minus minus is plus 9 because 3 times 3 is 9. Then replace the x by 3. So 1 over 3 times 3 is 1. Therefore, I'm getting e power negative 1 minus e power 0. Okay, when you replace the x by 0, so which is 1. So now you can do expansion. And at last, you'll be getting 9e power negative 1. This is the area of the shaded region, whereby we solve the question using integration by parts. Okay, now question 10. Let fx be the rational function. A express fx in partial fractions. So let me copy the function first. Now, when you look at the degree, the highest degree of x in the numerator, it is 2. But when you do expansion for the denominator, it is 3. So hence, you are given the proper rational function. So for all proper rational functions, we can get the partial fractions. So now, for the first term, the denominator is linear. Therefore, numerator is constant. For the second term, it is squared of linear. Okay, so even though it's squared, but we will start with degree 1, then followed by degree 2. If you are given degree 3, then you have to add one more term. So now, 2 plus x is a linear factor. Therefore, numerator will be b, and for the next one will be c. Now, the next step is to get the same denominator as in the left-hand side. Now, when you compare, okay, I have 1 plus x. This is 1 plus x. So I need to times by another square. So once you have obtained the same denominator, basically, you may cancel off the denominators from left and right side. That is the reason I am just writing down the numerators. So I will write down the numerators. Same for the b over 2 plus x. I need squared. Here only degree 1. Therefore, I need to times with another degree 1 and 1 plus x. So for the C, you already have the square of 2 plus x, so it means I need to times by 1 plus x. Then you will be getting the same denominator. Now, you have three unknowns, but just two linear factors. So to find the unknowns, we may let the factor be 0. Okay? So I will let 2 plus x be 0, which means my x is minus 2. So now you replace. So 2 bracket minus 2 squared plus 7 bracket minus 2 plus 8. As long as you see 2 plus x, that means the whole term will be 0. Alright? So same for the second term, that means I will be getting C. So 1 minus 2. Now from here, your C will be minus 2. Now next is let 1 plus x be 0. Therefore, your x is minus 1. So when you replace 2 bracket minus 1 square plus 7 minus 1 plus 8. Now the A bracket 2 plus x. So your x is minus 1. That means it's 1 squared. So because of the 1 plus x for second and third term, you will eliminate the whole second and third term. Therefore, you will be getting your A is 3. Alright, so lastly, you may substitute any other x. So the easiest is let x be 0. So left hand side 2 times 0 plus 7 times 0 plus 8. I will just write 8. Then it will be A is 3. 2 plus 0 is 2. 2 squared becomes 4. Plus B, 2 plus 0 is 2. 1 minus 1 plus 0 is 1. Then plus C. C is minus 2. And down here, 1 plus 0 is 1. Okay, so now rearrange. And you will get 2b equals to minus 2. Therefore, your b is minus 1. Now, just replace all the A, B, C that you have found. That's it for the A. So, I will rewrite. So, now my A is 3. So, 3 over 1 plus x. My b is minus 1. So, it's supposed to be plus minus 1 over 2 plus x. But please do not leave this as the final answer. The plus and minus 1 can be simplified to minus. Okay, same for the C. C is minus 2. So just write minus in the middle. Then 2 over 2 plus x squared. Alright, so with this, we have found the partial fractions for this function. Okay, next part. B, hence obtain. Again, hence means use the previous answer. Obtain the expansion of fx in ascending powers of x up to and including the term in x squared. So now I will rewrite. Just now my fx equals to 3 over 1 plus x minus 2 over 2 plus x, then minus 2 over 2 plus x squared. Okay, so now I will have to move up the denominator. So you will be getting 3 times degree minus 1 of 1 plus x minus 2 times degree minus 1 of 2 plus x minus 2 times degree of minus 2 of 2 plus x. Now, for this expansion, we need to refer to this binomial expansion formula, which is 1 plus nx plus n minus 1 over 2 factorial x squared, and so on. Now, the condition for you to apply this formula is the first term or the term without the x must be 1. Okay, so here 3 bracket 1 plus x degree minus 1, that's no problem because it's already 1. But then for the second term, we have 2 plus x degree minus 1. So I need to change this 2 to 1. Therefore, I need to factorize 2 from the 2. Alright, so when I factorize 2 from 2, I will get 1 inside the bracket. And the x becomes x over 2. So this whole term with degree minus 1. Same for the next term. So again, here is 2. So factorize the 2. And you'll be getting 1 plus x over 2. Okay, so now let me simplify one more step before the expansion. So this means the second term means the minus 1 is for both terms. Okay, the minus 2 is a degree for both terms as well. So I will rewrite first. It will be minus 2. So 2 power negative 1. Then 1 plus x over 2 power negative 1 minus 2 bracket 2 power negative 2, 1 plus x over 2 power negative 2. So now you can do the expansion since they are in the general form. So 1 plus my n is minus 1, so minus 1x followed by minus 1, then n minus 1. So minus 1 becomes minus 2 over 2 factorial x squared. Okay, plus minus 2. Okay, so here, let's say plus dot dot dot. Okay, minus 2. This 2 power minus 1 is basically half. Then 1 plus the n is minus 1. The x is x over 2. Then plus n minus 1 is minus 2 over 2 factorial x over 2 squared. Okay, and don't forget the last term. So minus 2 bracket. Now, for this, 2 power negative 2 is basically 1 over 4. So to do this expansion, remember your n now becomes minus 2. So I will get 1 plus n x. Then plus n minus 1, which is minus 3 over 2 factorial, and x over 2 squared. Okay. So from here, I will simplify all the terms inside the brackets first. So I will get 1 plus minus x is minus x. The next term here is going to be 1. Therefore, I'm getting x squared. All right. So then, half and 2 cancel. This 2 and 1 over 4 cancel becomes half. So after that, simplify the terms, negative. So 1 minus x over 2. So again, this whole term is 1. I will get x squared over 4. Then minus 1 over 2. Here is 1 minus x. Okay, all these terms becomes plus 3 over 4 x squared. So now do expansion. 3 minus 3x plus 3x squared. Then okay, let me check. I think there is a mistake. Okay, there's a mistake here. This is minus 1. Sorry, this is minus 1. It's not minus 2. So this is 1. Okay, mistake. So here is 1. So this 2 will be cancelled off. This half cannot be cancelled off. So which means here I will get negative half. Alright. So now this negative half bring in. So negative half. Then plus x over 4 minus 1 over 8x squared. Then here bring in. I will get negative half. Then plus half x minus 3 over 8 x degree 2. So simplify. At last, you will get 2 minus 9 over 4x plus 5 over 2x squared. Okay, so this is the expansion in ascending powers of x up to x squared. Okay, now, number 11, you are given a diagram. OABCD is a solid figure in which OA equals to OB equals to 4. That means here is 4, here is 4. Now, OD is 3. This is 3 units. The BH, OD is vertical. BC is parallel to OB. BC is here, parallel to OB. That means it's in the J direction. And the DC is 1. So, this is J. Now the base OAB is horizontal and angle AOB is 90 degrees. So AOB 90 degrees. Now unit vector IJK are parallel to OA, OB, and OD respectively. The midpoint of AB is M. This is the midpoint M. And the point N on BC is such that CN is 2 and B. So this is an N and here is a C. Alright, so now A, express vectors MD and ON in terms of IJK. So before we get the MD, we need to find the OM. So OM is half of OA plus OB because the M is the midpoint of AB. So half OA from the diagram, it is 4I, OB is 4J. Therefore, we will get 2I plus 2J for the OM. Now, MD is OD minus OM. So your OD is 3K minus 2I plus 2J. So now we arrange it so that it will be negative 2I minus 2J plus 3K. Okay, so MD is done. Now to get the ON, we need to refer to CN equals to 2NB. So CN is ON minus OC. NB is OB minus ON. So now do expansion, 2OB minus 2ON on the right side. So move the minus 2ON to the left side, it becomes 3ON equals to 2OB plus OC. Okay, so 2OB. Now OB is basically for J here. OC, let's see, what is your OC? Okay, now OC is OD plus DC. Okay, so it will be 3K plus 1J. That is your OC. So 3K plus J. So now I will get 8J plus 3K plus J. So that means you are getting 9J plus 3K. But this is the answer for 3ON. We need to get 1ON. So divide by 3. At last you get 3J plus 1K. That is the ON. Okay. So solution for A is done. Now B, calculate the angle in degrees between the directions MD and ON. So I let the angle, let angle equals to theta. So now use the scalar product formula. MD dot ON equals to magnitude MD times magnitude ON cos theta. So the MD is minus 2I minus 2J plus 3K. So I will write vertically minus 2I minus 2J plus 3K dot ON. Your ON is 3J plus K. That means it will be 0I plus 3J plus 1K. So the magnitude will be square root of minus 2 square plus minus 2 square plus 3 squared for the first modulus. And for the second modulus, it will be 3 square plus 1 square. Then cos theta. Okay, so for the left-hand side, it is scalar product. So minus 2 times 0 plus minus 2 times 3 plus 3 times 1. For the right-hand side, the first magnitude is square root 17. The second magnitude square root 10. Then cos theta. Now, for the left-hand side here, you will get negative 3. Okay, so theta is inverse cos -3 over square root 17 times square root 10. Now just use the calculator and you'll be getting 103.3 degrees. 1 decimal place. Right, so now C, show that the length of the perpendicular from M to ON is square root of 22 over 5. Okay, let's see the diagram. M to ON. This is our ON. Here is the M. Let's say here is 90 degrees. Let this be P. So you need to show the PM, the distance PM equals to the given value. So let me simply draw it. So let's say here is O, this is N, here is M. You need to get the P. Okay, so here means what is the PM length? Right? So now, first of all, get the OP vector. So before that, I will say that let's look at the diagram. Since it is perpendicular distance, that means vector MP dot vector ON, it will be 0, which is the properties of the perpendicular. So now, M is OM already found in the first part, and now we need to find the OP. So vector OP, since the P lies on the line ON, that means it will be the position vector of the P, which is OP, will be the vector equation of the line ON. So the line ON is passing through O, which is all 0, plus T of ON, because the direction is ON. So now my ON from the previous part, 3j plus k. So which means it will be 0, 3, 1. So from here, my OP is going to be 0, 3t followed by t. Okay, so therefore MP is OP minus OM. Then I will get 0, 3t t minus the OM we found in the previous part, which is 2i plus 2j. So when I write vertically, it's going to be 2, 2, 0. So when you simplify, first coordinate minus 2, second coordinate 3t minus 2, third coordinate is going to be t. Alright, so now substitute this into the formula. So minus 2, 3t minus 2t dot with ON. My ON is 0, 3, 1. Then equals to 0. So now this is the scalar product. So minus 2 times 0 plus 3t minus 2 times 3 plus t times 1 equals to 0. So I will get 9t minus 6 plus t equals to 0. Therefore, my t is, okay, I get 10t is 6. Therefore, my t is 6 over 10, which is 3 over 5. Okay, now I need to get my length of PM. Okay, so I can find the vector MP first. So now my vector MP is minus 2, 3t minus 2, and then t. T is 3 over 5. So when you simplify this, it's going to be minus 2 over 5. Oh, sorry, minus 1 over 5. And 3 over 5. Okay, so lastly, the length of the perpendicular is a modulus of PM or NP, which is the same. It will be the magnitude of vector NP. So negative 2 squared plus negative 1 over 5 squared plus 3 over 5 squared. So at last, you will be getting square root of 22 over 5. Okay, so with this, I have shown the length of the perpendicular. All right, so that's all for this video. Now, remember to subscribe to my channel if you enjoy watching my video. Okay, see you. Bye.